We are now on our part 2 of the exponents, where now the instruction has changed. You are no longer simplifying, but you'll be solving for x, since you are seeing solve for x. So this is our first sum, which is 5 to the 2x times a 5 being equals to 125. So we are to solve for x. Now we start by remembering all the laws that we are dealing with on the first part of the exponents. And now remember that whenever you are dealing with exponents, you must try to make either your bases to be the same or you make your exponents to be the same. So for this sum in particular, we can now just try to write what's on the right, which is our 125. We can try to express 125 in terms of having a base being 5. So we can write 125 as a 5 to the 3. And now this side, you're multiplying things of the same base, which means you'll have to add the exponents. Therefore, you'll go for your 5 to the 2x plus a 1 being equals to a 5 to the 3. Now I've made my base to be the same, so I drop the base. I remain with the 2x plus 1 being equals to a 3. Then I must make x out of the formula. 2x is a 3. Take the 1 to the other side, the sign will change. Then I have a 2x is equals to a 3 minus 1, which is a 2. Then I'll divide by 2 both sides. Is 2x divided by 2. So I may remain with my x. What I do on the left, I must do on the right. Is 2 divided by 2. Then these two will cancel each other. I remain with x. This side, 2 divided by 2, my answer is a 1. So my x for this sum is a 1. We'll now go on to do our second sum. Now we have a 9 to the exponent 2x minus 3. On the other side is equals to 27. So now we'll have to change our 9 to be a 3 to the 2. Then not forgetting to write what was given as an exponent. Also this side, this is a 27. We can try to make the base to be the same. So we can write a 27 to be a 3 to the 3. Then now, both must have to multiply out what we have on our left, which is a 2 times 2x. We'll get a 4x. We multiply a 2 times a negative 3. We'll get a negative 6 equals to a 3 to the 3. Now, as you know, that whenever dealing with exponent, you either make the bases to be the same or the exponents to be the same. So in this instance, we've made our base to be the same, is 3 to the 4x minus 6 is 3 to the 3. Then since the bases are the same, we drop them. We remain with a 4x minus 6 is equals to a 3. Then we'll take our 6 to the other side. The sign will change to be a plus 6. Then this is a 4x is equals to a 9. Then it's a 4x divided by 4. 9 divided by 4. What I do on the left, I must do on the right. So my 4 will cancel. I remain with x, which is a 9 over 4. You leave it like that since you can't simplify it further. So our x for this sum is a 9 over 4. Third sum, which is 3 to the x times a 3 to the x plus 1 equals to a 27 to the x. So now we'll still use the same principle of either making the bases to be the same or making the exponents to be the same. So in this case, we can go on to write what's on the left as it is for now. Then we deal with this 27, we express it in terms of a 3 to the 3, not forgetting the given exponent, which is x. Then on our left, we are multiplying things of the same base, so we'll have to add the exponents. So we will write one base, which is a 3, then add the exponents. This x will be a plus x plus 1 equals to a 3, then a 3 times x, you get a 3x. Then from here we have like terms, which is x plus x, which will give us a 2x plus a 1 equals to a 3 to the 3x. Now we've managed to make our bases to be the same, meaning that we'll drop our base, we'll remain with our exponent, which on the left we have a 2x plus 1 equals to a 3x. Then from here, we solve for x, we'll take 2 to the other side. On the right we have 3x, we take 2 to the other side to have minus 2x. Now, these are like terms. It's 3x minus 2x. We get an x, 1x, which this side that is a 1. Therefore, our x is equals to a 1. So our x for this sum, it's a 1. Yeah. Which is a 2 to the 2x plus 1 minus a 2 to the 2x minus 1 minus a 4 to the x equals to a 20. Mark allocation is 6. Still the same instruction. Solve for x. So we'll firstly have to break this down. We are seeing that the exponents are being added, meaning that we are having the same base. Then we added the exponents. So this was a 2 to the x times 2 to the 1 minus, we do the same with this one. We added 2 to the 2x times a 2 to the negative 1. Then we had to change a 4. We write it in terms of a 2, meaning that we'll have a 2 to the 2 to the given x equals to a 20. Then we go on to, let's just simplify that before we go to our next step. 2 to the 1 minus a 2 to the 2x times a 2 to the negative 1. Then here we'll have a 2 times x, where we have a 2 to the 2x is equals to 20. Then, now we are seeing that we have a common factor of 2 to the x. If you look here, we have a 2 to the x minus 2 to the 2x. Then here it's a 2 to the 2x, not a 2 to the x. Then our common factor here as well is 2 to the 2x. This side as well is 2 to the 2x. Therefore, I will take out a common factor. We write it down, 2 to the 2x. Then if I take out a 2 to the 2x on this first part, we remain with a 2 to the 1, which is a 2. Then I take out a 2 to the 2x. I get, this is a 1 over 2. I take out a 2 to the 2x. It's a minus 1. Then this side we still have a 20. So I've taken out my common factor of 2 to the 2x. Now I'll have to simplify what's on the bracket. We go to have our 2 to the 2x. Then this will give us a half a 1 over 2. Then this side still have this 20. So we are solving for x, meaning that we must make our x subject of the formula. So we have to remove this by dividing both sides by half, which is a 1 over 2, divided by a 1 over 2. What I do on the left, I'll have to do on my right. It's a 20 divided by a 1 over 2. So this side, these will cancel out. I'll remain with a 2 to the 2x. This side, I'll get a 40. Then, on this step, clearly we can't either make our base to be the same and we can't make our exponents to be the same. So if you have such a case, this is where you'll introduce your logs. If you can't either make your bases to be the same, you can't make your exponents to be the same, and you can't use the laws of exponents to solve from here, then you'll have to introduce your logs. So there's nothing difficult that we'll do. We'll just introduce our log. So it's a log of 2 to the 2x is equals to, I just write my log as well, I get a 40. So from this step, the next step, you'll have to just drop your 2 to the 2x. Your 2x, you drop it here, then you remain with this log of 2 equals to a log of 40. Then we'll divide both sides. I want to remain with x, this 2x, so I'll have to remove this log of 2. So I'll divide both sides by a log of 2. Then what I do on the left, I'll do on my right. This side I divide by a log of 2. Then these will cancel out. Then I'll remain with a 2x is equals to a log of 2 to the 40. Then we move on to this side. We get our 2x is equals to a log of 2 to the 40, which is, then from here, I want to remain with x, so I'll divide both sides by a 2. So what I do on the left, I'll have to do on my right. So I'll divide this log of 2 to the 40 and also divide it by a 2. Then 2 and 2 will cancel. I remain with x. Then from here, my x will be a 2,66. Then for the log, you can just punch this on your calculator to get the value. Then that value you divide by 2. Then you'll get your 2,66. That's how you deal with this sum. We are now on our fifth sum, where we are given a 9 times 3 to the 2x plus 1 equals to a 6 times 3 to the x. Then now you have to check your exponents. You see, it's 3 to the 2x. This is a 3 to the x. So we must let 3 to the x be equals to k. So now we go on this side, what's on the left, which is our 9 times. Now remember we said 3 to the x is k. Here we have a 3 to the 2x. But if I were to take just a 3 and x, 3 to the x, that's my k. But what remains, when I take 3 to the x, what remains is this 2. We still write that 2 plus a 1. Then we go to the other side, what's on the right, which is 6 times 3 to the x will change to be our k. Then we take this to the other side where we have now a 9k squared. We take this 6k to the other side, the sign will change, minus 6k plus 1 equals to a 0. Then from here, we'll then open two brackets as we factorize. This will be a 3k, which will give us a 9k squared. Then we'll have a 1 and a 1. It's a plus, it means our signs are the same in bracket. So I'll have a minus, it's sign of the middle term, it's a minus. Then from here, I then go on to take this first bracket, 3k minus 1 equated to a 0. Or this is a 3k minus 1 equated to a 0 as well. Now from here, you're going to say 3k, we take the 1 to the other side, the sign will change. Then you want to remain with k, meaning that we'll have to divide by 3, both sides. The 3 and 3 will cancel. Then I'll remain with k being equals to a 1 over 3. And on this side, we'll get the same. Since it's the same thing, even this side will have a k being a 1 over 3. But remember, we are not solving for k, but we are solving for x. So from here, we'll then go on to say, therefore, since k is equals to a 1 over 3, and my k is equals to 3 to the x. Therefore, where there is k, I'll substitute 3 to the x, which I then have a 1 over 3. Then my 3 to the x is equals to, take this to the top, it will be a 3 to the minus 1. The bases are the same, I'll drop them. I remain with my x being equals to a negative 1. Now our 60th sum, we are given a 5 to the 2x plus 1 plus a 5 to the x plus 1 minus a 5 to the x equals to a 1. So we'll still use a K method as well. But firstly, let's just break these down, where we take our 5 to the 2x times a 5 to the 1 plus a 5 to the x times a 5 to the 1 minus a 5 to the x is equals to a 1. So from here, we are seeing that you have a 2x and you have an x. Same here is 5 to the x. So we take the lower exponent, we let 5 to the x be equals to k. So from here, we now know that if I take a 5 and x to be k, I'll remain with this 2. So I'll have this k squared times a 5 plus 5 to the x, we said we let it be k, it's k times 5 minus 5 to the x is a k equals to a 1. So from here, we go on to write this thing in a standard form, 5k squared plus a 5k minus k is equals to a 1. These two are like terms. We are having a 5k minus a 1k. So we go on to say 5k squared, 5k minus 1k, we get a 4k equals to a 1. Then we take our 1 to the other side, we remain with a 5k squared plus a 4k. The sign will change, equated to a 0. Then we factorize to have a 5k and a k. Then we have a 1 and a 1. It's a negative, it means that our signs are different. Then the bigger bracket takes sign of the middle term. Here we'll have a 1 over 5. This side will have a 1. So the bigger bracket is this one. I will have a plus. This side will have a minus. Then we go on to equate our brackets to a 0. 5k minus 1 equals to a 0, or a k plus 1 equals to a 0. We solve for k, it's 5k is equals to a 1, divide by k both sides, 5k, 1 divided by 5, divide by 5, then our 5 will cancel, then we remain with k being equals to a 1 over 5. This side will have our k being equals to a negative 1. Then we remember that we are not solving for k, we are actually solving for x, so we still have to continue now to solve for x. So we had said our 5 to the x is k, so now we'll change our k. We're going to say 5 to the x is equals to a k. Then we now know that our k is 5 to the x, which is equals to a 1 over 5. Then our 5 to the x is equals to a 5 to the minus 1. We have made our bases to be the same. We get our x being equals to a negative 1. Then on the other side, where we are having this k being a negative 1, we know that we can't simplify it further, meaning that if I were to take 5 to the x being equals to k, and then now I go on to say this is 5 to the x being equals to a negative 1, from here you can't solve for x in this instance, so there's no solution for this side. So we just have our x being a negative 1. Yeah.